Hi everyone. So let's start solving today's leetcode question 1345 jump game 4. There are different versions of jump game. This is the fourth version and this is marked as hard. Okay, I don't think it is a hard problem, but let's see why it is not a hard problem. So let's understand the question first. So I have given an array of integers ARR and I am currently standing at initial position like the first index of the array. What it means, if I have given an array error, I am currently standing at the 0th index. Okay, and I can take three kinds of jump. Jump one is I can go to I plus 1, but I cannot go out of bound of array length. If I say array length is n, then I cannot reach n or greater than n. Okay, and I can jump to I minus 1 index. This is the second kind of jump. But I cannot go less than the 0th index, like I cannot go minus 1. Okay, and there is a third kind of jump. This is an interesting one, that I can jump to any index j where ARR of I is equal to j, but I is not equal to j, and I need to return the minimum number of steps to reach the last index, which is means n minus 1. I need to reach n minus 1 in minimum number of steps. Okay, so let's understand this example. What it said, explanation, you need three jumps, okay, from 0 to 4. First I go to 100 to this 100, but this is third jump, okay, third kind of jump, this one. So I go to 100 to 100, then I took second jump, which is I minus 1, this one, okay. Then I go to take one more third kind of jump and read the last index. And in this case, I took one jump, 1, 2, and 3. So total numbers are 3. That's why the answer of this problem statement is given as 3. Okay. So how to approach these kind of problem? As these are hard questions, so our first step is to write all the observations. क्या क्या observations है सो देख लेते हैं. So first observation क्या है कि हम कैसे कैसे jumps ले सकते हैं. तो जंप्स कैसे ले सकते हैं, आई प्लस वन पे जा सकता हूँ, आई माइनस वन पे जा सकता हूँ, और किसी भी रैंडम जे इंडेक्स पे जा सकता हूँ जहाँ पे ए आर आर ऑफ आई इज इक्वल टू ए आर आर ऑफ जे है, बट आई नॉट इक्वल टू जे है, बट आई नॉट इक्वल टू जे है. ओके, सो ये मैं थ्री जंप्स ले सकता हूँ. सो एक बार इस एरे के इंडेक्सेस लिख लेते हैं, 0 1 2 3 4 5 6 7 8 9 एन इज इक्वल टू 10. करेक्ट, 10 लेंथ का एरे. अगर मैं 9 पे पहुंच जाता हूँ तो मुझे मिनिमम नंबर ऑफ स्टेप्स रिटर्न कर देने हैं. ओके, सो मुझे पता है कि मैं इनिशियली जीरो इंडेक्स पे खड़ा हूँ. ओके, सो जीरो इंडेक्स पे खड़ा हूँ मैं. इसके इंडेक्स भी लिख देते हैं. यहाँ से मेरे पास थ्री चॉइसेस है. मैं आई प्लस वन पे जा सकता हूँ. इसको थोड़ा और एक्सपेंड कर देते हैं. ओके, दिस इज माई I plus 1, this is my I minus 1, and this is the third jump, third variation of jump. Okay, okay. So I plus 1, can I go to I plus 1? Yeah, ये n minus 1 से तो छोटा ही है, तो मैं आगे तो जा ही सकता हूँ. So where I can reach minus 23, which is at index 1. Now, can I go to I minus 1? No, it violates the out of bound. Okay, so I cannot go to I minus 1. So this jump I cannot perform. Third jump. So can I go to any index where the ARR of I is equal to ARR of j? So that is the fourth index. So I can go to 4. I reach another 100. Okay. Now from minus 23, I can have again three choices. Okay, I can go to I plus 1, which is minus 23 again, which is at index 2. I can go to I minus 1. Yes, I can go to minus 1, 100, which is at index 0. And I can go to, there is any another minus 23 present? Yeah, minus 23 present at index 1. Okay, now let's where I can go from 100. I can go to I plus 1, I minus 1, and the same. Okay, so I plus 1 will be 23, which is present at index 5. Okay, I can go to I minus 1, which is 404, which is present at index 3. Okay, is there any another 100 present in the array? Yes, at 0 index. Okay, so let's try to see if I reach minus 23. Okay, I reached I plus 1. Okay, from here where I can go, I have again three choices: I plus 1, I minus 1, and the same index 1. Okay, so from here I reached I plus 1, which is 404, which is index 3. Then from 203 I minus 1. I minus 1 is 1th index, minus 23, which is index 1. Then can I go to another 23? Yes, minus 23 is present where? At 1th index. Okay, but okay, let's try to come this. So here I can see 100 of 0. I reach 100 of 0th again, but I started from 100 of 0th index. So isn't it a repeated call? This index I processed already and I visited it again. So isn't it a repeated call? I can avoid this because I processed already. Same as minus 23, I started from minus 23 at first index only. So this is a repeated call. I can avoid this because I already visited this index and processed this. Okay. If I see this 2305, I still have three choices: I plus 1, I minus 1, and the same index. What will be this? I minus 1 will be 100, which is present at 4th index. Then I am having, oh, no, this is I minus 1. I need to go to I plus 1. Just 23, which is present at 6th index. Okay. Then I can go to I minus 1, which is at 100 index. 100 at index of 4, and another 23, which is at 6. Okay, but is there only one 23? No, there is one more 23, so I can add one more branch, which is at index 5. No, at index 6, at index 7. Okay, now let me see this 404. Okay, so for 404 I have three choices: I plus 1, I minus 1, and the same 404. So I plus 1 will be 100 at index 4. I minus 1 will be minus 23, which is at index 2. And the another 404, which is present at index 9. Let me start with this. Okay, 4043. Okay, okay. The same way we can reduce the same like the already processed nodes. So here 1004 I already processed. 2306 this I need to process. Okay, but I can get the result from this, so this will be considered as again processed. Okay, and 104 it is already processed here. So I can reduce my calls from this because I already processed this. Now minus 23 of 2 which I already processed here. Okay, so I cannot go inside this. Now 40, isn't it my base case? I reached last index, so I can return from here only. Are you understanding? And what is this? If you solved any tree problems, this is nothing but BFS, breadth first search, or we can say level order traversal. We are traversing level by level. First, we started from 0th node, then we took all the three jumps, then all the situation, other three jumps, like this. And where this is my base case, when I reached the last index, I need to return at that point only. And how can I reduce like these jumps which are already processed? Can't we use a visited data structure of something where visited of that particular data structure tells me, bro, that this index is processed or not. So with the help of visited data structure of any kind, let's suppose I took boolean array of type visited, which will tell me if that is true, that means that particular index, if that is true, or it can be false. What does true means? That that particular node or that particular index is processed, and that particular index is not processed. So I can go ahead with the false one. If it is true, I can simply do not go inside that traversal. I can not move forward. I cannot move forward in this. Not move forward in this. Not, no, no, no. Okay. So in this way, I can traverse my whole array in the way of BFS. Okay. And this is my base case. If index is equal to n minus 1, I need to return my jumps. Now how to calculate jumps? So at each level, my jump is getting incremented by 1, correct? So after every level order traversal, after every level, I will increment my jump with 1. Okay. So let's come to time complexity. टाइम कॉम्प्लेक्सिटी पे आने से पहले एक बार कोड देख लेते हैं इसका, ठीक है? सबको समझ तो आ गया हमें कि हमें क्या करना है कि अच्छा, एक चीज हमने डिस्कस नहीं किया, वो क्या है कि अब हमें ये इंडेक्स भी तो फाइंड आउट करना है ना जहाँ पे सेम एलिमेंट प्रेजेंट है। 100 से मुझे थर्ड काइंड ऑफ जंप भी तो लेना है, 404 से 404 पे भी तो जाना है। सो ये मैं कैसे ऑप्टिमली रिट्रीव कर सकता हूँ एरे से? सो फॉर थर्ड काइंड ऑफ जंप, let me remove this before time complexity. I need to reach I need to reach all j where ARR of I is equal to ARR of j. Can I traverse a whole array again and again? No. I need to reach jth index in order of 1 time complexity. How can I achieve this? Can I use a hash map for that? Hash map where for all ARR of I will be storing the indexes in a list. So hash map of type where I will be storing ARR of I and list of I. Let me write indexes. If I use this hash map while level order traversal, I can get all the j's where ARR of I equal to ARRJ in order of 1 time complexity. Okay. Okay, so let's jump to code once so you will get an idea. Okay. So I created one hash map integer where integer will be ARR of I and list of integer will be of indexes. I created a boolean visited array of maximum size as per the constant 5 into 10 raised to power 4. Okay. And I initiated my queue. Then I started filling my map. Okay. And visited of 0 because I currently started at 0th index of my array. So I marked visited of 0 as true. Okay. And I started level order traversal for all the levels. I incremented my jump and I get all the indexes from my map. So indexes is nothing just a list which I get from map.get ARR of front. Front is what? The first element of my queue. First element will be in the first level, it will be the 0th index. So ARR of 0 will be 100. So I will get map.get 100. All the indexes of 100 I need. Okay. Then I pushing all those indexes into my queue for the next level order traversal with the constant property I am satisfying. And I'm also checking that those nodes should not be visited. If it is visited, I can skip those. Okay. Now I need, yeah, that's it. Okay, so let me try to submit this. So I'm able to submit this. Okay. Now I was getting TLE in some cases in the like large test cases. So what I need to do to reduce like if I visited one index, so I do not have to visit it again. For that, in the map reference list, I am clearing that list. So there will be no index present. I need to visit again after I reach that particular index. So for that, I am clearing that indexes list. Indexes list is nothing. The list stored in the map. So I am clearing that particular list inside the map, not the retrieved one, because indexes store the same reference. Okay. So if I talk about the time complexity, order of n for generating the map,